Algae are some of the oldest and most simple organisms on our beautiful planet, existing everywhere there is nutrient-rich water and sunlight. There are over 300,000 different algae strains, but only a handful are utilized for commercial purposes to be used around the globe by health-conscious individuals for a variety of dietary needs. At the bottom of the food chain, algae have been the basis for the renewal of life on Earth for many years. They are quite simply some of the most important organisms on the planet. Here at New Earth, our focus is on high-quality wild microalgae, which has the scientific name of flos-aquae, or more simply AFA. Native to Klamath Lake in the high desert region of southern Oregon, AFA is a species of blue-green microalgae chock full of vital nutrients including pigments, vitamins, minerals, antioxidants, essential amino acids, essential fatty acids, and many other phytonutrients, all of which provide a wide range of health benefits. Nestled in the Cascade Mountain Range at an elevation of 4,100 feet, anchored in porous volcanic earth with an average depth of 8 feet and nearly 300 days of sunshine a year, Klamath Lake enjoys a unique ecosystem. At more than 20 miles long and 8 miles wide, the lake is one of the largest natural freshwater lakes west of the Mississippi River. The secret of the lake's nutritional potency lies in the pyroclastic rock that gently filters water through its 35 feet of mineral-rich sediment. Add to that the network of pristine snow-fed mountain tributaries and springs that feed the lake, and you have the ideal home for wild microalgae, Earth's original superfood. The life cycle of AFA flos-aquae is like any other. There is new life, growth, decline, and then birth of a new generation. In the winter, AFA settles in the sediments at the bottom of Klamath Lake in the form of specialized cells called aconeids. Aconeids are regenerative cells that spawn a new generation of AFA every spring. AFA obtains its energy through photosynthesis, so in the late spring these aconeids begin to germinate in response to an increase in water temperature and sunlight. The microscopic cells begin to multiply, forming long, thin filaments. The filaments then join together to form colonies that are visible to the naked eye. These AFA colonies look like small blades of grass floating in the water. As the conditions become optimal for growth, AFA enters into an exponential growth phase. This is the summer bloom. It is at this time that AFA is so abundant in Klamath Lake, the harvest season begins. One of AFA's secret weapons is the ability to fix nitrogen. Specialized cells called heterocysts convert atmospheric nitrogen that is dissolved in the lake water into a usable form of nitrogen. Nitrogen is a limiting nutrient for the growth of plants, and because AFA makes its own, it outcompetes all other algae and dominates the lake's microalgal ecosystem. The summer harvest generally lasts only for a few weeks in July. When the lake water becomes too warm to support AFA growth in August, the bloom disperses. In September, as the conditions are again optimal for growth, there is another AFA bloom and harvest. In late fall, as the waters cool and there are fewer hours of sunlight, AFA begins to decline. AFA senses that winter is coming and begins to produce aconeid cells for the following spring. The aconeids settle into the sediment at the bottom of the lake, where they remain throughout the winter. And when the lake begins to warm the following spring, the cycle of life for wild microalgae begins again.